Hello and good morning. I, Yash Khanshani, welcome you all to this video lecture series of class 9th mathematics. In my previous video, we learnt about terminating and non-terminating decimals. Okay, we solved the first question. Now I am going to tell you the trick about those questions. Okay, how we can directly, without dividing, tell whether the number is terminating or non-terminating. See, we were having the first question was 36 upon 100. See, on dividing we get directly 0.36, but for example, if the number is something else, so what we have to do, we have to check the denominator. We have to check the denominator. If the denominator is in the form of 2 raised to the power m into 5 raised to the power n. I am telling you what is this 2 raised to power 5 m and n. Okay. See, on factorizing 100, what do we get? If we get the factors in the form of 2 and 5, okay, we are having factors of denominator 100 in the form of 2 raised to the power m and 5 raised to the power n. So if the number is such, we can directly say that the expansion would be terminating. Okay, we have one more question, that is question number 6. See, it is 329 upon 400. Okay, without dividing, how could you tell? See, on factorizing, what we are going to get, we are having 100 here, 2 into 2, okay, 4 into 100, okay. So it is 2 into 2 into 2 raised to the power 2, 5 raised to the power 2. It is 2 to the power 4 into 5 to the power 2. Okay, the denominator is in the form of 2 raised to the power n and 5 raised to the power n. Okay, now we can say directly that this is terminating. Okay, without dividing. Okay, only by prime factorization we can directly say whether the given is terminating or non-terminating. Okay, now we have dealt with question number 1 and 2 in my previous video. Now we would be seeing question number 3. What does question number 3 says? Okay, question number 3 is representation in the form of P upon Q. See, we have only 3 questions, but we would be dealing with more of them. See, for example, how to solve this question. You can give answer by tricks also and by method. So firstly we would see what is the method to solve these questions. See, for example, if we are having 0.5 bar and we have to represent in the form of P upon Q. See, 0.5 bar could be written as 0.555 and so on. Okay, so let us suppose that x equals to 0.55555. Okay, now give this as equation number 1. See, now we have to see that how many digits are having bar. Only one digit, 5. See, if one digit is having a bar, so what we would do, multiply equation 1 by 10. One digit means 1 0 after 1. Okay, so multiplying it by 10, so what it would be, it would be 10x equals to 5.5555 and so on. Okay, on multiplying 0.555 by 10, what we get, 5.55. Give this as equation number 2. Now what we would be doing, subtracting equation 1 from 2, or you can simply write 2 minus 1. Okay, that is 2 minus 1. So in LHS, 10x minus x would give us 9x, and in RHS 5.555. see, this whole term after decimal is being cancelled, so what we get, 5. So x would be 5 by 9, and what we have supposed that x is equals to 0.555. so we have converted 0.5 bar into fractions. Okay, we have converted 0.5 bar into fractions. Similarly, if we are having a 2-digit repetition, see it, if the question is 0.23 bar, bar is on both the digits. Okay, now what we would do, we would suppose that let x equals to 0.232323 and so on. This would be our equation number first. Okay, now since two digits are repeating, so what we would do, we would multiply both sides by 10, by 100, sorry, by 100. Since two digits are repeating, so two zeros, okay, by 100. On multiplying by 100, what do we get? 100x equals to 23.2323 and so on. Give this as equation number 2. Okay, now similar process, 2 minus 1, 100x minus x is 99x, and on RHS 23.232323, and the number after decimal is same, so we get here 23. Then you can write simply x equals to 23 upon 99. Okay, x equals to 23 by 99. So one thing you must have observed, that when this single digit was repeating, so what do we get as answer? 5 by 9. 5 by 9. Okay, and here two digits are repeating, so what do we get as answer? 23 divide by 2 times 9, 99. So for these kinds of question you could directly give the answer, but for this kind of question only, so this method or this trick won't apply. Now let us try solving these types of questions. Okay, these types of question by looking at question number 2 of our exercise, which is 0.47 bar. It is 0.47 bar. Question is 0.47 bar. Only bar is on 7. Okay. Now the process would be similar. Let x equals to 0.477777 and so on. This would be our equation number 1. Okay. Now since one digit is repeating, so multiplying both sides with 10. Okay, multiplying both sides with 10. So what do we get? 10x equals to 4.7777 and so on. This would be our equation number 2. And the similar process, 2 minus 1. So on subtracting 10x by x, we get 10x minus x equals to 4.777 minus 0.477. Okay, 10x minus x is 9 times x, and 4.7 minus 4 is 3, and rest gets subtracted. Okay, now what would be x? X would be equals to 4.3 by 9. Removing this point, we would get 43 upon 9. 43 upon 90. Okay, so this is our answer, and we have represented this question as P upon Q. Let us see one more question. If we are having the question, suppose it is 1.23 bar. 1.23 bar. So how could we solve these questions? It is similar. Let x equals to 1.23 is repeating. Let it be first equation. Since only a single digit is repeating, so multiply equation 1 by 10. So it would be 10x equals to, what do we get? We get here 12.333. Okay, and so on. This is our equation 2. Then 2 minus 1, 10x minus x is 9x, and here 12 minus 1. 12 minus 1 is 11 point. 3 minus 2. 3 minus 2 is 1. And rest 3 are cancelled. Now x would be equals to 11.1 by 9. On removing this decimal we get here 90. Okay, so this is how we would be dealing with these types of questions. Okay, now you could easily solve the first question, which is 0.6 bar, and the third one 0.011 0.001 bar. Since 3 digits are repeating, so we would multiply by 1000. Okay, now the fourth question which we are having is express. We have to express (0.99999) in the form of p upon q. See, it could be written as 0.9 bar, or you could directly let x equals to 0.999 multiplying by 10, we get here 10x equals to 9.9999. okay, this was our first equation. This is our second equation. 10x minus x is 9x, and we get here 9 minus 0, 9.0. okay, x could be written as 9 by 9 or simply 1. Now you might be thinking how this is equals to 1. See, when 0.9999, it is just near about 1. It is just near about 1. On rounding up, we would get 1. So 1 is the correct answer for this. Okay. Now fifth question is express 1 by 5 in decimals. Okay, 1 by 17. So what would you get on dividing 1 by 17? Okay, start dividing. Then it would be 100, and when you divide this whole complete, you would get the answer. And you see, this answer would be a terminating and repeating decimal expansion. Okay, now majorly we have to see this question number 7, which is write 3 decimal expansions which are non-terminating and non-recurring. Non-recurring means they are not repeating. I have told you in my previous video when I was explaining you about non-terminating and non-repeating decimal. For example, 001, 3 times 01, 4 times 01, 5 times 01, and so on. See, these kinds of decimal are non-terminating, they are never going to terminate, and they are non-recurring. Similarly, 3.03. okay, we can have many of them. What you feel like you can make. Okay, now the seventh question. Seventh we have done. 8. Right, find 3 irrational number between 5 by 7 and 9 upon 11. See, how we have to write 3 different irrational numbers. So how can we do that? Firstly, we would divide 5 by 7. Okay, 7 sevens are 49. We get here 1. 7 ones are 7. We see only 2 digits of decimal are sufficient. And on dividing this, what do we get? Okay, so it is 0.81 bar, and this is 0.71. Now we have to write decimal numbers between 0.71 and 0.81. okay, between 71 and 81 we get 0.72. now we have to write irrational number, so 02, 002, 0002, and so on. Similarly, 0.73. okay, similarly, so we have plenty of numbers. You have to write any 3 of them. Okay, now the last one is to classify the following as rational and irrational. to classify the following as rational and irrational numbers. Okay, so first one is square root 23, since square root of prime numbers are irrational. Okay, second is square root 225, which is 15 square, and 15 is a rational number. Okay, third one is 0.3796. It could be represented in the form of p upon q, thus it is also a rational number. Okay, the fourth one is 7.478478 and so on. So it is 7.478 bar, thus it is non-terminating but repeating. So this is also a rational number. Okay, now the fifth one is 1.0100010001. Since it is non-terminating and non-repeating decimal, so it is an irrational number. Okay, so we are done with 1.3. I hope you find this video helpful. Do like and share my video. If you haven't subscribed my channel yet, press the subscribe button and bell icon for more updates. If you have any doubt, you can mention in the comment section below. Thank you.